My name is Fei. This is my final project presentation for the course Principles of Big Data Processing at Harvard University Extension School. My final project is processing and analytics of New York City taxi trip data. Outline. I will introduce project goal, data source, architecture and technologies, implementation overview, result, and demo. The goal of the project is to build a big data system that can visualize spatial temporal patterns of taxi activities with index taxi trip data. And it can also make predictions on trip duration based on machine learning of taxi trip data. The data source is New York City green taxi trip record data. It's publicly available. The green taxis are one of the two major types of taxis in New York City. They operate in certain areas of New York City area. The data are stored in CSV file. Each CSV file corresponds to 1 month. The data from February to May in the year of 2016 are used in this project. Here is an example of the CSV file. It has fields like pickup time, drop-off time, pickup latitude, longitude, drop-off latitude, longitude, and some other fields. The taxi trip data are stored into HDFS. There are two paths from here. The first path is to index data into Elasticsearch and then visualize them in Kibana. The second path is to build a machine learning model using Spark MLlib. There are 4 tiers used in this project. Storage tier, which I use HDFS, indexing tier, Elasticsearch, ES Hadoop, Spark connector, and visualization tier, I use Kibana, and there's also a predictive analytics tier. I use Spark Core and Spark MLlib. Here is the implementation overview. First, I download the CSV file, 4 months green taxi trip data, and copy them into HDFS. And then I index taxi trip data into Elasticsearch using ES Hadoop Spark connector. Specifically, I load trip data as RDD, and each trip record is translated into a document and put into Elasticsearch. And then I visualize the taxi trip activities aggregated by space, by time, by space plus time in Kibana. And on the other hand, I build a regression model with the taxi trip data using Spark MLlib. Specifically, I derive some new features from existing fields. For example, time of day, pickup location geohash, drop-off location geohash distance. Then I build a random forest regression model to predict trip duration based on those features. And then I evaluate and save the model to HDFS. Let's move on to results. Here are some visualizations I generated in Kibana. So the heat map on the upper left corner shows the pickup activities aggregated by space. The red color corresponds to a high density area. The bottom 2 graphs shows the taxi activities aggregated by time. So for example, this is the daily activity. We can of the past 4 months, we can see a clear cyclic pattern. So 7 days is 1 cycle. Okay. This is a visualization that shows the taxi activities aggregated by space and time. It shows the spatial pattern of taxi activities at 8 o'clock in the morning, which is 13 o'clock UTC time. Okay. The color represents different densities. So this slide shows the results of the machine learning tier, the predictive analytics tier. So I built a machine learning model of trip duration using time of day, pickup location geohash, drop-off location geohash, and distance for Tuesday For each day, I build a separate model. So there's a Tuesday model. So the root mean square error on the test data is 424 seconds. The mean absolute error on test data is 273 seconds, which is roughly 4.5 minutes. And here are some sample predictions. Okay, let's move on to demo. I'm going to show some code first, and then a visualization example. Here's a code that indexes text-to-trip data into Elasticsearch. It reads CSV file, converts the records into document, and then put them into an index called TextC 2016. This is code that conducts the machine learning task. It reads CSV file, it generates some features by transforming existing fields, and build a regression model using random forest regressor, and then evaluate the model using different metrics, and then save the result to HDFS. Let's move on to a visualization. This is a visualization in Kibana. You can see I have a filter here, pickup hour equals 7. This map shows the density of pickup activities across space at 7 o'clock in New York City. Different color represented different density. Okay, that's the end of my presentation. Thank you.